Please like, subscribe, and put on your notification. Thank you.
Hi everyone, my name is Igiodu Benga, one of the mathematics facilitators of Tutelage Educational Services. And today I want to take us through a very interesting and prolific topic titled Pythagoras Theorem. The name of our topic is Pythagoras Theorem. The importance of Pythagoras Theorem cannot be overemphasized because it serves as the bedrock for every concept concerning trigonometry. Now, before any further ado, let's look at the originator of the theorem itself. The propounder of the theorem itself is named Pythagoras of Samos. Pythagoras of Samos. A brief profile about him. He was born between 580 and 569. He died about 500 BCE. He lived in Samos, an island off the coast of Ionia in Greece. Pythagoras was a mathematics teacher and a philosopher. Now let's look at the theorem itself. Pythagoras rule. What did Pythagoras find out? He was able to find out that the areas of two side squares add up to equal the area of the long sloping square. He was able to find out that the areas of two side squares add up to equal to the area of a long sloping square. Here you can see we have two squares here that are side by side. The square with the red color and the one with the yellow color. The square with the red color, you see the units, it has the 4 units and the area is 16. And the square with the yellow color has 3 units and the area is what, 9. Now if you notice a square that slopes across the two squares, which is of green color, the unit is 5 and the area is what, 25. You now see that if you sum the area of the red square and the yellow square, it gives us the area of the sloping green square. But that's not that. If you check in between the 3 squares, you can see a particular shape there. And the shape is a right angle triangle. That's where we are going today. The shape in between the 3 squares is a what? Right angle triangle. So in conclusion, we can say that Pythagoras theorem states that the two sides of a right angle triangle, the square is equal to the sloping side, which is known as the hypotenuse. The sloping side of the right angle triangle is known as the hypotenuse. Now we can have it here that the triangle with side A, area A squared, and the square B with area B squared, and the square C with area C squared. You can see there that in the right angle triangle formed with side A, B, and C, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. So invariably we can say that C squared is equal to A squared plus B squared. We can say that C squared is equal to A squared plus B squared. That's what Pythagoras theorem is about. So now in between these 3 squares, you can see the square painted with black and the square painted with, although it's a sketch, painted with red, and the square painted with what? Blue. You can see that the area covered by the black square and the blue square, the area covered is times 2. The area covered by the blue square is times 2 of the area covered by the black and the blue squares. So here we have a right angle triangle formed in between the 3 squares. We have a right angle triangle. Now remember that a square, all the sides of a square are equal. So whether this length of this particular square and this length, they are equal. This length of this particular square and this length, are equal. Also, this length of this particular square and this, they are equal. So now let's look at the right angle triangle formed in between these three squares. This particular side is A, the length is A, the length of this other side is B, and the length of the sloping side is C. Remember when I read the theorem, the sloping side is called the hypotenuse, and it is the longest of the three sides. Now, what is a right angle triangle? A right angle triangle is a triangle that has a right angle. One of its angles is a right angle, because from our previous classes we will have learned that the sum of angles in a triangle is 180 degrees. But a right angle triangle is a particular triangle that has one of its angles at right angle, meaning one of its angles is 90 degrees, and it's usually represented with this rectangular shape. This is now how do I verify that this particular side is my hypotenuse, regardless of how the right angle triangle is drawn? The hypotenuse is opposite to the right angle. The side facing the right angle is the hypotenuse. The side facing the right angle is the hypotenuse. We call it the hypotenuse. And it's the longest of the three sides. And from Pythagoras theorem, we have that the square of the hypotenuse is equal to the sum of squares of the other two sides. The square of the hypotenuse is equal to the sum of squares of the other two sides. That's the reason why any question that deals with right angle triangle, or even in some cases other form of plane shape, this particular formula or this particular theorem can be applied. Now, if we have our c squared to be equal to a squared plus b squared, now how do we get the c, which is the hypotenuse, if we want to derive our hypotenuse? Now, since we have squared here, since we have c squared, for us to be able to get our c, we'll look at the opposite of what square, which is what square root. We take square roots of both sides. We take square roots of both sides of the equation. So if I take the square root of c squared, I'm going to also take the square root of a squared plus b squared. Now, if you take the square root of a square number, it becomes the number itself. It's just like taking the square root of 16. Remember, the square root of 16 is the same thing as 4 squared. So the square root of 4 squared is 4. So the square root of c squared is c. So c will be equal to the square root of a squared plus b squared. Now, from Pythagoras theorem, we can be able to verify that the hypotenuse is equal to the square root of the sum of the squares of the other two sides. Yes, we have an example here, a right angle triangle, where I have that one side, the length of one side is 8 centimeters, and the length of the other side is what? 6 centimeters. Now, the length of the sloping side, which remember, we said it is the hypotenuse side, is unknown. It's represented with x. So now we are told to find x. Even remember from the question, we were not even told to use Pythagoras theorem. But because it is a theorem that has been proven to be right, we can go ahead to use it. Now, remember, from Pythagoras theorem, we said that the square of the hypotenuse is equal to the sum of squares of the other two sides. But in this case, our hypotenuse is related with what? X. So here we can go ahead to say x squared is equal to 8 squared plus 6 squared. So we have that our x squared is equal to 8 squared. The square of 8 means 8 times 8. To square a number means to multiply the number by itself. The square of 8 is 8 times 8, which is 64, plus the square of 6, which is 6 times 6, is 36. So thereby we have that our x squared equals 64 plus 36 is 100. Is 100. So our x squared is 100. So what is our x? From what we did earlier, we have to take the square root of x for us to get x. We have to take the square root of x squared for us to get x. So now let's take the square root of both sides. The square root of x squared, because we have done that to the left hand side of the equation, we must do the same to the right hand side of the equation, equals the square root of 100. The square root of x squared is x, and the square root of 100, the square root of 100, we are looking for the number that when you multiply by itself, you give you 100. The square root of 100 is 10. So the unit is centimeter, so our x is 10 centimeter. Our x is 10 centimeter. So the hypotenuse for this right angle triangle is 10 centimeter. Note that we were not told to use Pythagoras theorem, but with the knowledge of Pythagoras theorem, we've been able to know that, oh, if we have the unit, what shape are we looking at? This is a right angle triangle. We are given two sides, and we have one unknown side. We can apply the rule of Pythagoras, or we can call it the theorem of Pythagoras, which states that the square of the hypotenuse side is equal to the sum of squares of the other two sides. And how do we verify the hypotenuse side of a right angle triangle? It is the side facing the right angle. It is the side facing the right angle. So the length of x of this right angle triangle is 10 centimeter. The length is 10 centimeter. So in conclusion, Pythagoras or Pythagorean theorem, it states that when we are given the length of legs A, which is of this blue square, and B, which is of the orange square, the length of the hypotenuse, which is the slope square with the green color, can be found using the formula a squared plus b squared equals to c squared. Or we can say c squared equals to a squared plus b squared. Now let's assume the length of c is 5, the length of b is 4. Now we want to find the length of a. Remember, since c squared equals to a squared plus b squared, it follows that a squared will be equals to c squared minus b squared, or b squared will be equals to c squared minus a squared. So a squared will be equals to c squared minus b squared. A squared will be equals to c is 5, that's 5 squared, minus b is 4, minus 4 squared. So a squared equals to 5 squared, which is 25, minus 4 squared, which is 16. A squared is equals to 9. And if we take the root of both ends of the equation, the square root of a squared is a, equals to the square root of 9 is 3. So that's that on Pythagoras or Pythagorean theorem. The importance or the beauty of Pythagoras theorem is that we can't talk about trigonometry without referring to Pythagoras theorem. Trigonometry is a branch of mathematics that deals with measurement of triangle. Trigonometry is formed from two Greek words, trigono and metron. Trigono implies triangle, and metron means metric, which means measurement. There is no way we'll be discussing trigonometry, the sine function, the cosine function, the tan function, angles of elevation, angles of depression, the sine rule, the cosine rule, and so on and so forth. There is no way we can be discussing these trigonometric ratios without referring to Pythagoras theorem. That's why I said earlier that the importance of Pythagoras theorem can never be overemphasized. The application of Pythagoras theorem can never be emphasized. Thank you for listening to today's class. Till next time we meet, stay blessed.